In this problem, we're asked to draw a possible graph of the function f given information about the derivative of f prime. This is a little bit different than other problems in that we're actually trying to find information about f given information about its derivative. So here's the example. We know that for x less than 2, f prime of x is less than 0. That is, f prime is negative. We're also told that f prime of x is positive when x is actually larger than 2. And finally, we're told that the derivative is 0 when x is equal to 2. So this is information about the derivative. We actually want to find what is the original function f, or give some idea of what it looks like. Well, let's try to graph this. Again, we're trying to graph f, not the derivative of f. So here we have the x-axis. And the key point here is when x is 2, right? X less than 2, x bigger than 2, and x equals 2. Those are the three different possibilities. So if I put 1 and 2 and 3, the thing I have to keep track of is what happens around 2. The last piece of evidence tells me that if the derivative is 0 when x is equal to 2. So that means either I have a peak or a valley at 2. For derivative less than 0, that means the slopes of the tangent lines are negative for x less than 2, which means it's a decreasing function. So over this interval, f is decreasing. And if x is bigger than 2, then the derivative is positive. So f is increasing. Okay, so now let's use this to draw our graph. So before 2, all the way up until 2, we are decreasing. So that means I'll draw the graph something like this. And then at 2, I have to have a horizontal tangent line because the derivative is 0. After 2, when x is bigger than 2, the derivative is positive, so f is increasing. So I start increasing. And that's it. That's a possible graph of our function f that satisfies these three conditions. Now your graph might look somewhat different, but as long as it satisfies these three conditions, it's okay. For example, here's another possible graph. It's decreasing up until 2 and then increasing after 2, and the derivative is 0 at 2. So there's many possible graphs, but they all have to have this kind of look, right? They have to be coming down and then up, and they bottom out at 2.